In this section, we are going to talk about EIGRP optimization with together. The first thing we are going to focus on is the EIGRP query process. If the router loses access to any path and does not find a feasible successor for the path in the topology table, it queries its neighbors with the query information for that path. And this router is called as the active router. Let's take a look from the figure, and let's say that this router lost the connection to 10.10.1.0 network. And whenever this router loses this network, that sends query message to all its neighbors in the network and says that, hey dude, I lost my connection to 10.10.1.0. Do you have any backup path for this route for me? And as I told that, this router is known as the active router. Active router means that the router that's sending query messages and waiting for the replies from the other guys. Let's take a look to the output. In the output, this router has active state and passive state. The passive state is for 10.3.9.0 network, and the active state is for 10.2.4.0 network. Active means the router is actively seeking an alternate path for the destination. Passive means everything is okay. I'm connected to this network and I'm receiving the routing updates and there's no problem with the path. But if the router is in active state, there's a problem. And that means we are sending query messages. And to limit the query packets, we can use EIGRP summarization and EIGRP STUB options. STUB configured routers do not forward routes learned by EIGRP to other neighbors, and more importantly, non-STUB routers do not send the query message to STUB routers, and this saves the bandwidth. For example, let's say that router B has lost the connection to 1.8.0/24, and because of router C and router D does not have any path to another network, as I wrote like here, we can define these guys as STUB router, and whenever a query message is tried to forward it in here, router C says that, dude, don't send me any query message because I don't have any path that you don't know. And here is the STUB options. When we type EIGRP STUB, we can configure the STUB configuration like this. In the config router mode, in the EIGRP mode, we need to type EIGRP STUB, and when we type the question mark, we can see the EIGRP STUB options. By default, a STUB configured router will share the connected plus summary routes with its neighbors. If you configure receive only, router does not share any route with any neighbor. And the other options are redistributed, static, and leak map. And after the question mark, as I told from the previous slide, if we just hit the enter, which means we just type EIGRP STUB, we just advertise connected plus summary routes. If we type receive only, the router just receives updates and does not advertise any routes. If we type static, that is used for advertising static routes. And if we type connected, that's used for advertising the connected routes. And here is the EIGRP stack in active. For example, let's say that this network, 1.0 network, is down, guys. And there is no feasible successor. Then, as we talked in our first slide, router 2 sends query message over all its interfaces. Query, which says that, hey man, do you have any alternate path to 1.0 network? Also, router 1, router 3, router 4 and router 5 to start to sending query message for this network. Query comes to router 1. Router 1 says that, dude, I'm sorry, I don't have any path to this network, for example, and sends query to other guys saying that, hey, router 3, hey, router 4, hey, router 5, do you have any alternate path for the 1.0? Router 2 is asking me that. After a while, as you can see, query message start to tire the network and consume too much bandwidth. And please keep in mind that router 3 doesn't send the query back the router 1, which it got from router 1 because of the split horizon rule. And for instance, let's say that router 5 has a direct connection to the 1.0 network. Then router 2 should wait defaultly 3 minutes and hear back the answers of the all other query message answers before making a decision, even if the router 5 says that, hey man, I have a backup route for the down network. And after 3 minutes, router 2 destroys all the neighbor ships and reestablishes it. And this process is known as stuck in active. To prevent this problem, we have two solution methods: EIGRP summary routes and EIGRP STUB. Let's talk about first the EIGRP summary routes, and let's assume that networks between 102.70 are working behind router 2. And here, let's say that we have these networks. If these networks are summarized as, for example, like 00/21, and for example, let's say that if just 1.0 is down, router 2 will send the query message again, as you know. But other routers will say to router 2 that this time, hey dude, you told me that the networks beginning with 172.30 is behind me, and they will send rejection message so that no query storm will occur. And the second method is EIGRP STUB, using EIGRP STUB. STUB networks means the network that is going to nowhere, like router 3, like router 4, like router 5. They have no other connection, as you can see. If we configure router 3, router 4 and router 5 as STUB, router 3, router 4 and router 5 say that I am STUB to router 2 when neighborship is being established. And router 2 understands that, dude, I know you have nowhere to go. The networks that you told me are the end of the way. So that if this network is down, no query messages are sent to router 3, router 4 and router 5. So we can save our bandwidth, as you can see. Let's talk about the EIGRP auto-summarization now. EIGRP automatically advertises the summary route information to other EIGRP routers, and this auto-summarization is disabled after Cisco iOS version 15.01 and can be manually disabled with the no auto summary command. As you can see that we have 3 separate routes, and we are summarizing these 3 separate routes with just one route on router 1. To verify if we are using EIGRP auto-summarization or not, we can use show IP protocols command, and we can check that if the auto-summarization is enabled or not. And the other verification method is using show IP EIGRP topology command, and we can check that if we are seeing via summary on this output or not. EIGRP automatically summarizes networks as classful, as we can see. And let's say there are 2 routers that advertise this network, but they may actually want to advertise this (10.0/24) and 20.0/24. These guys are advertising this via auto-summarization, but what they want to advertise may be just to 10.0 or 20.0 networks. This may cause a problem. For example, another router in the network wants to reach to 10.0 network, but 2 routers are saying the same thing. Hey, whatever starts with 172.16 is behind me. So, which path we are going to use? Are we going to use the path, this one, or are we going to use the path that's being advertised the other router? So the correct solution is auto-summarization should be turned off always, and we should use manual summarization if necessary. And here is how we can configure the EIGRP manual summarization. The command is IP summary address under the interface mode. We use IP summary address, EIGRP autonomous system number, and the network we need to summarize. As you can see, we are using 10.20.0.0 with 255.252.0.0 subnet mask, and we are representing these 4 different routes with just one route. EIGRP can distribute traffic across multiple links to the same destination to increase bandwidth utilization effectively. EIGRP has the ability to make load balancing equal or unequal. By default, you can load balancing up to 4 equal paths in EIGRP, and only feasible successor paths can be used in load balancing to make sure there are no loops in paths in EIGRP. For example, if I'm using EIGRP and if I need to make unequal load balancing, I can send 2 packets from that link and 1 packet from that link. That's the capability of the EIGRP. If the backbone router wants to use unequal load balance for accessing 2.0/24 network, let's take a look at our figure. The network is here. To configure this guy to make unequal load balance for accessing this network, we are using the variance command. And under the EIGRP mode, we just type variance and a variance value. For this example, we are using 2 packets for here and just 1 packet for the other path perhaps. And to verify the EIGRP load balancing, we are using show IP route command. And in the show IP route, we can see that for this network, we have 3 different paths. The first path is being learned via 1.2, the second path is being learned from 2.2, and the third path is being learned from the 3.2.